Mahlzeit. This is my electric bike, and I built the battery myself using these lithium-ion cells. Why? Because I'm a hero and I dropped the battery I bought on my very first test ride. Unfortunately, it didn't explode. To be able to buy that battery in the first place, I had to sell one of my kidneys. And since I figured I should probably keep the second one, I had to come up with a different solution. Since I love procrastinating my studies, I went deep into the DIY battery rabbit hole, watched hours of videos by people much smarter than me, and here's what I learned. Lithium-ion batteries are made up of many individual cylindrical cells. Standard sizes are 18650 and 21700. In my battery, I'm going to use the Samsung INR 21700 50S because they match both my budget and performance needs. Depending on the voltage and capacity you want, the cells are connected in series and then in parallel. For my hub motor, I need 48 volts, which means I need 13 cells in series. To get 50 amp hours, I have to connect 3 cells in parallel because one cell has 5000 milliamp hours. This setup is called 13S 3P. To connect them, you need cell holders and nickel strips. These strips need to have a certain thickness depending on the power output of the battery. The strips are then spot welded to the cells. I got myself some 0.2mm nickel sheet. It was much harder to find online than the standard nickel tape everyone uses, but I'll explain why later. To be honest, I could make an entire video about spot welders, but I chose this one and I'm happy with it. To detect irregularities in the cells and charge the battery evenly, you need a BMS, a battery management system. I bought one that can handle 40 amps, more than enough for me, and it has Bluetooth so I can monitor each cell. Because if I'm going to explode, I'd at least get a push notification first. To build a battery like a professional, you also need Kapton tape, large heat shrink tubing, wires, fish paper, and epoxy sheets. You can find everything I used in the video description. Last point, these things are very dangerous. If you don't know what you're doing, don't do it. The perfect project for me. If you decide to build one yourself, it's at your own risk. I'm just some guy on the internet who has no idea what he's doing. Once all the parts finally arrived, I went to my workshop. There I have more space, more peace and quiet. And well, the floor isn't flammable. This whole thing requires precision, technical knowledge and sense of responsibility. So basically the three things I absolutely do not have. Perfect project for me. Since I'm not as dumb as I look, I covered the entire workbench to avoid accidentally short-circuiting everything, which would definitely cause an explosion. I also removed all the jewelry I wasn't wearing. First step, check the voltage of every single cell using a multimeter. It's super important that all the cells have the same voltage, otherwise when you connect them, a high current will flow between them, the cells will heat up and... Luckily, all my cells had the same voltage, so I could go ahead and place them into the holders. To get the 48 volts, I had to alternate the polarity of each group of 3 cells. I triple checked that, because if even one cell is facing the wrong way... Now I can finally explain why I'm using nickel sheet instead of nickel strips. A lot of the nickel strips sold online aren't actually nickel, they are steel or hilumine. That has way worse conductivity, so I 3D printed this pressing tool. It forms the nickel sheet pieces, which I cut by hand with scissors, into the exact shape to go over the bumps and connect 2 cell groups. In theory, these should easily handle 50 amps, way more than I need. For the end connections, I designed a different pressing tool. Before I start spot welding the nickel sheets to the cells, I first solder this 10 gauge wire to the nickel on the positive and negative ends. I do this beforehand because otherwise I'd heat up the cells too much, and they really don't like that. By the way, soldering directly onto the nickel tape or gluing the cells together with hot glue is a terrible idea. Because then, you guessed it. Anyway, I first activated my inner factory worker and cut out the remaining nickel strips and pressed them into the shape. Jeff would be proud. On one of the cells from my gutted broken battery, I tested which settings were right. To be safe, I put on the gloves I stole from my urologist. I slowly worked my way from cell group to cell group, always careful that the Big Bang 13.8 billion years ago would remain the only one. Every finished connection I immediately covered with Kapton tape and sealed all the exposed spots. Because any short circuit could lead to... nope. To protect the areas I wouldn't need to touch anymore, I cut and glued small pieces of epoxy board. Why epoxy board? No idea, but everyone else does it. Then came the part that scared the crap out of me the most. Wiring the BMS. The BMS is actually there to monitor the battery and shut it off in case of overload. Kind of ironic that wiring it is the part with the highest chance of making the battery go ballistic. But fine, that's what I signed up for. The manual that the Chinese included really wasn't the eierlegende Wollmilchsau. Oh, you don't know what a eierlegende Wollmilchsau is? Let me fix that.
Clear your throat and yell with flair. It's time for Deutsch that makes you stare.
Today we are talking about the eierlegende Wollmilchsau. And no, that's not a new Pokemon. Literally translated, it means egg-laying Hool milk pig. So basically an animal that lays eggs, gives Hool, produces milk and is also a pig. Pretty much the ultimate egg-Hool milk sausage machine. In English, you would say something like a jack of all trades or a mythical all-in-one solution. You use it when describing something that's supposed to do everything, but is completely unrealistic. Like a phone that makes coffee, drives your car and does your taxes. And the remaining open spots are covered with more epoxy boards and fish paper. At the very end, everyone wraps their battery in that huge shrink tube, and since I jumped off a bridge if everyone else did, I wrapped mine in shrink tube too. I was about to buy a heat gun for it, but my grandparents' hairdryer did the job just fine. Saved money again. The BMS also has Bluetooth, and since I film with my iPhone, I can't show you live how it looks, so here's a screenshot. You can see the voltage of each cell group, the internal temperature, and you can actually adjust everything. I was careful with that at first, because that kind of thing could make the battery think it's a great idea to explode. Very proud, I took my softpack home, sat down at my PC all eager and starting thinking about how the case should look. The biggest inspiration for me was this e-bike battery mount. So I just had to design a box that fits the battery and split it into 4 parts because it would be too big for the Bambu Lab otherwise. I quickly printed it at home in red PLA and glued it together. It fit perfectly, but somehow I wasn't happy. It all felt too easy, looked bulky, and I wouldn't have been able to remove the softpack later since I'd have to glue the halves together. I thought about it for a long time and then I had an idea. I've been making funny jokes this whole time about the battery blowing up in my face, so why not make it actually look like that? I already had red PLA and that's the perfect color for a bundle of dynamite. So I sat down again, designed, thought, looked for inspiration, and in the end it was perfect. Or so I thought. Because I, the genius, didn't combine the XT90 connector with the lid. I put it on the opposite side. That meant I couldn't have easily taken the softpack out of the shell. Even worse, I couldn't glue the middle section together because there was so much tension on the cables. Whether I just printed again. Problem? I didn't have enough red filament left. But then I had a stroke of genius. I just reprinted the lid and made a plug for the bottom part that I could glue in. That way I could finally complete the battery. Okay, but how does the whole thing attach to the bike? For that, I got a piece of sheet metal from my favorite hardware store. I first made a template out of cardboard and transferred it onto the metal. Unfortunately, that's when I realized that cutting and bending sheet metal isn't exactly a scissors and go job. I did have an angle grinder, but a bending brake? No, too expensive. After a bit of research, I found an open workshop just 20 minutes away by car. They had both a metal shear and a bending brake. I didn't film any of it, I just forgot it. But as you can see, everything worked perfectly. Then I just mounted everything onto the bike and professionally tightened it with zip ties. The worst part though was the wiring. About 1,000 tiny cables that all needed to go to the right place, and a few big ones that looked like they would cause serious trouble if you even looked at them wrong. Once the cable chaos was under control, I was just about making everything look nice. I printed a cover for the controller and the cables, and I'm just hoping the PLA doesn't melt away in the sun. Also, my girlfriend used her plotter to make the typical TNT lettering, so that everyone knows, don't mess with me. On the day of the first test ride, I was really nervous. Would the battery behave the way it should or the way it looks? Would the bike even work right? Would I get electrocuted while riding? I could have kept asking questions like this forever, but I just turned the key, got on, and the bike moved. I was super happy because I was a bit worried the bike chain might have an issue. Well, not yet anyway. Pretty soon, another question came up. How far can I actually go on a full charge? On paper, I should get about 50 kilometers, And for everyone still doing math using Excind Imperial Wizard units, that's about 30 miles. So I grabbed my fully charged battery and did what any sensible engineer would do. I drove around my grandparents' house, again and again and again. Because one lap is almost exactly 1 kilometer, which is perfect. No GPS, no spreadsheets, just pure count-the-loops technology. I did 10 laps, so 10 kilometers. And at that point my fingers were so cold, they basically filled a resignation letter and left my body. After a short break, I went out again and did another 10 kilometers. Now, here's the part where I confess a crime. I forgot to document the state of charge properly. Yes, I know, I'm the worst, but after those 20 kilometers, I definitely had 62% left. And you just have to trust me on that. So yeah, 50 kilometers should be doable, especially considering it was 1 degree Celsius during the ride. That's 34 degrees Fahrenheit, which is basically freezer with wind. Unfortunately, on the last run, a tire exploded.
Nein!
But honestly, whatever. This was never really about tires. This was about how to build a battery and potentially also about how to slowly become a cautionary tale. Thanks for watching, don't forget to subscribe. Tschö.